What was your favorite talk so far? This one, right? I'm super excited because of serverless. How many of you use serverless already? Big show of hands. Okay, so for you, maybe it's not going to be like nothing new. This is like very beginner. So I'm assuming like for people who never use serverless, so I'll be giving some code examples, some links. So we'll be using AWS, and of course, we'll be using JavaScript. Okay, so let's get started. First of all, let me introduce myself. My name is Azad Marden. I've wrote 14 books on JavaScript and node.js. We did a book signing just a few hours ago. Thanks for showing up. I see some familiar faces for React Quickly, my latest book. I also have Node University, where I publish online courses. And I really like my coffee with coconut milk. Tried it with butter, but I like coconut milk better. So if you've heard about coffee and butter, or you can just Google it, you'll find some recipes. Some of my books, not all of them about JavaScript and Node.js. A couple of them are business books, non-fictional business books. So one book is how to write books, right? So after I've written like a dozen books, I'm like, okay, so maybe my next book is how to write books. It's called Prog Writer, Programmer and Writer. And you can see my picture. I was, so like a cartoonish picture, Programmer and Writer. Another book is Prog Writer 2.0. So that's a book, what to do after you've written books. So like speak at conferences and do online courses, stuff like that. And here's the 5 hacks to get the job of your dreams to live a happier and healthier life, right? So we all want that. Well, I'm just sharing my story in that book, and actually, I do have a dream job. I worked at the small fintech startup you probably never heard of. It's called Capital One. It's famous for its Viking commercials, especially like this one, using a cactus. I promise this is going to be a last GIF. So my experience related to the cloud and DevOps, right? So before we used to have DevOps, it was like a separate field, a separate profession. You needed to know hardware about 10, 15 years ago, and you would go into those data centers. You would actually put your physical racks, your physical hardware, and make sure they're connected. And now we have this term, it's called DevOps, right? So it's kind of a hybrid. You do a little bit of IT operations, but you also do a lot of development. And why is that? Well, first of all, the technology is better now. There are services which they allow you to do certain things, which before you have to like be an expert and spend many, many years to know. And serverless is one of them. And so before I started as just an app developer or software developer, I was just throwing my code, just creating zip files and sending it via email, even before sending it via email to IT ops. And it was a magic to me. I didn't know how they would install my applications, but they were always complaining. I don't know, it works on my computer. They were complaining. DevOps. So now, so after that, I joined a startup. Now it's part of Adobe Systems through a series of acquisitions. But at that startup, we were just a small team of just 5 developers, 5 engineers. And we served traffic coming from the White House blog, BBC, CNN, all those news, big news agencies. And we were able to leverage cloud. And that was a real eye-opening for me. I used AWS, I used Joint, and I could see that you can accomplish a lot with those elastic resources, very scalable, flexible resources. But still, at that stage, we had to like go in SSH. I remember one time our founder, he had still keys to production. He was riding Mooney, which is like a public transportation in San Francisco, and he was restarting our production servers on his iPhone. There's an app that you could use, which is crazy, so don't do that. And then I discovered Heroku, and I discovered those wonderful platform as a service solutions, which it's a step further. They allowed us developers to do way, way more. And not worry about SSH access, not worry about patching your OS, installing some new packages and modules. And now I use cloud in the enterprise. Capital One is one of the big adopters in the fintech of cloud. And it's really, really great because those cloud technologies, typically they have PaaS. Obviously, they have the lower level, which is just virtual machines, but they have platform as a service. And now we have serverless, which is you don't even need to know anything about OS. You just tell a version of your application environment, and you can run. So it's even more abstraction than what we had before with PaaS. So in this walkthrough, we will be using 3 services. We'll be using DynamoDB, which is a NoSQL database. It's a key value database. There are many types of NoSQL databases. I saw a talk on CouchDB. It's another popular NoSQL database. So NoSQL databases, they're allowed to do more custom queries than just a traditional database. And DynamoDB, it's a proprietary database from Amazon Web Services. And it's very easy to get started with DynamoDB, and you don't have to install anything. All you do is just create a table. Lambda. So Lambda, that's the proprietary service from AWS. It's a functions as a service. So that's our serverless. It's at the core of the serverless, right? So when people say serverless, they typically would use also API gateway, because API gateway, that's what really, really allowed people to start using serverless technology, those functions as a service, as the backend. Before you still had Lambdas. You had Lambdas probably for 6 or 5 years. So it's not a new technology, it's not a new service. But it was mostly for triggering some alerts, for doing some metrics, et cetera, et cetera. It was more or less internal tool. API gateway allows you to also trigger those functions when you have incoming HTTP requests. And that's how we build RESTful endpoints and RESTful APIs. Basically, we can build the whole infrastructure, the whole system with those 3 technologies using Lambda, API gateway, and for database, you can use something else. But in this example, I'll be using DynamoDB. And this tutorial will consist, first we will create a DynamoDB table. How many of you have AWS accounts? Oh, wow. Like pretty much all of you. Okay, so you can hop on the Wi-Fi and follow this tutorial alongside. And in the end, you will have a fully functional RESTful API. Okay, so let me give you a link. So I'll just jump straight to the end and give you the link. Okay, so take a picture of this link. So you can just follow and do the same commands, the same exercises, and we'll have enough time. If you know what to do, it will take you maybe like 10, 15 minutes, and I will be explaining you what to do. So it's github.com/azat-co, that's my GitHub username, and /AWS intermediate. You don't have to type the entire URL. You can just go to that repository, which is AWS intermediate, and then find the code folder. Inside, you would find a folder serverless. So pretty obvious, right? Code, serverless. So I have 5 or 6 files with the scripts. Okay. So I'll be moving along. If you didn't have time, then you'll get a chance to copy that later, or just look at your neighbor. So first thing, let's create a DynamoDB table. The way DynamoDB works, we don't create an instance. So each region in AWS will have one instance. So we don't create a separate database. Like in MySQL, there is a create database command. So in DynamoDB, the instance is already there, but we can create a new table. Okay, and even before you start, so if you have your AWS account, we will be using command line, AWS command line. You can also do pretty much everything via the web console, which is the website. But CLI is better. CLI is better because you can automate it, you can save, and I wrote a few AWS command line scripts as well. So in order to make the CLI works, what you would need 2 things, access key and the secret. You can create a new user, or you can use existing root user. I recommend create a new user in your web console, copy the secret and the key, and configure it using this command, AWS configure. It's at the bottom. So that will save your key and secret and make them default when you use AWS CLI. This is how you can use AWS CLI. So AWS, that's a command for your CLI tool, which you need to install it. It's a Python-based tool. And then you have the service name. So DynamoDB, that would be the service. AWS has dozens and dozens of services. So EC2 is one of them, and DynamoDB is another. So that's the naming pattern. And then after DynamoDB, you have the command, what to do. So let's create a table. So we create a table, and then we obviously need to pass the name of the table and some of the attributes, such as schema and reading capacity, etc., etc. If you use a slash like this, it's just for me to format the slides. You don't actually need the slash. It's just so you can see the command better on the screen. Okay. Then after we create that DynamoDB, each resource in AWS, it has ARN, Amazon Resource Number or identifier. So it's like a unique identifier by which we can get that resource. So this is how it looks like. If you cannot see it, it's basically AWS :DynamoDB. Then you have a region. You have your account number. Mine starts with 16, 15, 999. And then you have table / and your table name, which is messages in this case. You can also get the list of tables using this command, describe table. And then if you don't provide the table name, you would get the list of the tables, existing tables. If you provide the table name like I'm doing right now, table name is messages, you would get the description. This is a command to get all the tables. Okay. Step number 2. So we're done with step number 1. We created DynamoDB table. Step number 2, now we need to create a permission so our serverless function can access DynamoDB. Amazon uses 2 policies. One is called trust. This is how it looks like. It has a statement. And I'm just providing you the trust policy file. So in that GitHub repository, which I showed to you, or you can click on this link, you would get this JSON file, basically. This is how it looks like. So we have action, and then we have statement. So basically, it's called a trust policy, and we need it for the serverless function to access DynamoDB. But that's not all. We also need to attach a certain policy. A certain policy it's in addition to the trust policy. So we need both of them. It will enable the access to the DynamoDB, and you can see it's a managed policy. Amazon DynamoDB full access. What is a managed policy? So basically, you don't need to specify each access policy individually. You can just use this name, such as policy / Amazon DB full access, and Amazon already knows what you want to do. You want to give the full access to the DynamoDB, to that serverless function, so serverless function can access the DynamoDB. You would not get output from that command. And this is some of the examples. This example, it gives access to the logs. So if you want to add more inline policies instead of the trust, so first you create a trust policy and then you attach inline policies, you can do it as well. Okay, step number 3, we create the actual Lambda function. Okay, it's very easy. You can use web editor, but we continue with the CLI, with the command line tool. I'm sure no one can see this. That's why I have this link to the GitHub repository. Let me actually open it in a normal editor. Of course, I need internet connection. So the way we're going to upload this file, we will just zip it, and that's how we will upload it. ATO exclamation mark, right?
Yeah.
So while we're waiting for Wi-Fi to connect, the function would be just an index.js file. It will be in this. Well, actually, I should have it here. Yep, I have it here. So use strict. This is something to enforce ECMAScript, the latest ECMAScript. My next talk would be about the state of JavaScript right after this one. So we would definitely want to use the latest, the best JavaScript syntax. And this is what you can see, this fat arrow syntax. And how many of you ever worked with Express? Express.js, like half of the room, right? So in Express, you get you build routes and you have request handlers, right? Each request handler has request, response, and then maybe next. So something similar here: event, context, and callback. So this will be provided by AWS, and then event will have all the information, and context will have some additional information about this incoming request. And then the callback will just calling callback when we're ready to send back the data. So we can look at this done function, for example. It calls a callback with a special property, status code. So 400, that's client error. So if the data is wrong, if we don't have enough data, we would send 400. That means a client error. Okay, 200. That means everything is okay. So if there is no errors, send 200. If there is an error, send 400. And then the body. Either send the message, the error message of the body, or send this JSON stringify. So I'm stringifying the response because the response needs to be in a string. I'm not just sending an object. And then headers. So header would be application/JSON all the time. This is the response. And this is my actual function. It has a switch. I know Douglas Crockford said don't use switch and case, but that's what's in their example, and that's what I copied and modified to create my function. So we have 4 methods: delete, get, put, and post. So your typical CRUD. What is CRUD? Create, read, update, and delete, right? So based on the HTTP method, we would be doing a different operation. For example, delete, dynamo.delete item. Where is this dynamo is coming? Well, it's actually a library, DynamoDB/-doc. Some of those libraries, they're already available to you in the AWS. Others, if for some reason you have a library which you need to include, just put it in your zip file and along with other source code, push it to the cloud. Then we have get. So dynamo.scan, this is like in MongoDB.find. So it's a read query. And we need to provide the table name. Okay? Because there are many tables, we need to say, okay, what is the table name? And the table name would be coming in the query string. What is a query string? That's in the URL after the question mark. So the key would be table name with a capital T and name. And then we have put and update item. So put creates an item, update item updates it. This is coming from the body, and then when we don't have any matches, it will be just unsupported method. Okay. So as you can see, it's about 50 lines of code, very straightforward, and it also works for any table, not just one table, because we didn't hard code that table name. Right? So depending on your business case, you might want to have this RESTful API for any tables. You might want to add some validation. Obviously, for example, here, you would want to add validation. Right? You don't want to just save any data which is coming from the post body. Right? So you can do all of that. JavaScript is just JavaScript. Right? And so just copy that file from my GitHub repository. I still Connect, I guess it's overloaded, that's why I cannot connect. Yeah. That's right. Okay, so this is the command that will take our zip file. So you see file B. That B stands for binary. And then you just point it to your file. So obviously you need to be in the same folder, or you need to provide the folder in that path. And remember that role, that IRN role. So this is what we will attach to this function. So you would copy this from a previous command, from step 2, when you create a role. IAM stands for Identity Access Management. It's like a separate service in AWS. Other parameters, you can see memory size, timeout, handler. So handler, that's what you would invoke on your function. So if you go back to the code, let's minimize it, go back to the code. Remember this name, handler. In Node.js, there's a magical object. It's called exports. So everything you attach to exports, such as handler, you can come up with your own name. All those properties, the properties of exports, they would become exposed. So if anyone requires this as a module, they will get access to this function, right? And in your command line, in your AWS command line, you specify the name. So actually, you can have multiple functions in one file. It doesn't have to be one file per one function, right? But by changing the name, which you have in the source code, you would actually map the Lambda function to your source code, to the function that you are exporting. So let's, by default, there would be, the size would be 128. And I'm changing it to 512, just to make sure it's not timing out too early. And you can see the runtime, Node.js version 6.10. So by changing that value, you can also change the version in which your function is running. So version 6 is good, version 8 is better, version 4 is not good. This is the output. So we will get the SHA, we will get the function name. This is the same name that I provided in the function name. So this is very important because by using the name, we can invoke the function later. And then I have some other information. So let's test the function, right? So by now, it should be working. It should be connected to MongoDB. So I created this mock JSON file. It's kind of mimicking my HTTP request. Just a JSON file, api-test.json. And if you have that GitHub repository, it's also inside. So I can feed that data and invoke my function. So it's not a real HTTP request. I'm mocking my request by providing this object, which looks very similar to what AWS will provide when I'm actually will be triggering. So by this point, there is no endpoint, so I cannot make a request. We still have to create that. That's actually the biggest step, the hardest step. But I can still test my function using AWS CLI. This is how I do it. AWS Lambda invoke. Obviously, I need the name of my function. It's just a global name, unique name per account, per region. And then the payload, that's what will be provided. And the output.txt, that's the output that I'll be getting. You can also do that in the web console, just copy pasting it. This would be the output. The output would have the status code, 200. It would have 0 items because the database is empty. The table is empty, so I don't have any data. If you're using some table which has some data already, then your field will be populated. But at this point, our Lambda is working. Our Lambda is working. Now, the next step is to actually make an HTTP request. So in order to make HTTP requests, we need to expose this function. And the way we're exposing it, we're creating an endpoint, RESTful endpoint. And that endpoint will trigger our function. Okay? So this is the biggest step, the hardest step so far in this entire tutorial. So first of all, we'll need to create a REST API in API Gateway. API Gateway, it's a separate service. And then we'll need to create a resource, such as /accounts or users. In our case, it would be, because the function can work with multiple tables, so we'll just name it DB API. It's like a RESTful API, not just one entity. Then we need to define HTTP methods with OAuth. Then we need to define integration to Lambda. So it works sort of like a proxy. Your request will go to the API gateway, and then it will be passed to the Lambda. So we need to connect them. And then we need to create a deployment. Okay. So the process is not straightforward. That's why you can either use Web Console, or you can use a script, which I created. And AWS intermediate. And let's walk through the code of this create API. So it's the function, it's just a bash, it's just a shell script. But what I like about it, now you don't really need to understand all those 5 or 6 steps. You can just run it. And pretty much it will integrate your Lambda function and create a RESTful endpoint. So first of all, we are setting up API name. That's the API, that's the REST point name that we want to create. Then we're setting up the region. If you don't set it up, it might take it from your default configuration as well. And the function name. So db-api, it must be the same function name which you created before. And then we start executing our commands. So if you're not familiar with Bash, if you're not an expert in Bash, double quotes, $, curly braces, that's like interpolation. So I'm outputting a variable value. So API name will be substituted with this value. And then in the description, I will use the name of my function. And the region will be US West 1, which is San Francisco. So this will create API gateway. It will, in the API gateway, it will create a RESTful API. And then I'm outputting the API ID. And also I'm running this command to get the parent resource ID. We will need to use it later. So the next command, we need to create a resource. That's where we use that parent ID. And let's just wrap it around. OK. So this will have the query string. The query string will be basically extracting certain values that we will be using later, such as table name. So create resource. Then we create a put method and put integration. So this was very confusing when I was writing the script. The put method doesn't actually refer to the HTTP put method. Okay, you might think, oh, I'm creating a put method. It's like, then I would need to create a post method. No, no, no. Put-method is just an AWS CLI command. Okay, the actual method is here. It's any. So at this point, you have control. So you have very granular, very good control at the API gateway level. You can control what type of requests are coming. So in this point, I'm just opening up to any request. It could be head, option, put, post, delete, etc., patch. But in your particular application, probably you would just have 2 or 3, right? Especially if you're using microservices approach. You would have it as small as possible. Then another good thing that API Gateway gives you, it's authorization. So you can set up 3 different types of authorization. You can have an API key. You can set up different authorization. Or in this case, I'm saying no. Just open it to everyone, which is obviously not a good idea. But for the purpose of this exercise, it will make our example simpler. And I'm saying no API key required. Okay? So at this point, I'm creating those methods on my RESTful API. Put integration. So now I need to connect this resource, this API gateway resource, the RESTful API, to my Lambda function. So again, I'm saying method any, API proxy. So this is another very important thing, which took me a few hours of trial and error to figure out. Type AWS_proxy. And I'm also providing, of course, I need to provide the function name. function name, and I'm doing it here. So I'm using URI, which is like a ARN, like a Amazon Resource Identifier. So that's almost done. The last step is to create a deployment. So now we're deploying. Why do you need this extra step? Well, think about it. You might have different versions of your APIs. Okay, so create a deployment. So you can say, okay, this is prod, this is QA, this is stage. So you can also have different versions of the same API exposed. So this is, again, it gives you flexibility. And after that, add permissions. So I'm giving permissions for this API gateway resource to invoke my function. Okay? And then I'm providing the response. So response, again, you have control at the API gateway service to also massage and format the response as well. So what you're getting from function, it's not necessarily what your clients need to get or can get. You can add some extra headers, you can add some extra formatting or status code. So for example, I'm just saying always output 200, right? But in my code, I sometimes have 400 as well. Okay, whew, that's finally all. It's like 5 or 6 commands, but lucky you don't have to go through all that pain. You can just download the script and run it. So when you run it, this would be the output. Yeah, a little bit small, so let me show it to you in the editor. This would be the output. So I'm echoing IDs, API ID. So if one step fails, you can go back and trace, did that resource was actually created. So at the end, you would get this URL. It would look like some randomly generated string. Then you'd have the prod. So again, remember that prod, you can change it to stage or test or any other URL. So this way you can have multiple versions. DB API, so this is the name of our function and also the name of our resource. It could be /accounts, /transactions, /users. And here's our table name. And I'm getting the response, at least I should be getting it as empty. Okay. Anyone was following me? Did anyone get to this point? No, not yet? Okay, we still have 15 minutes, 15 or 20 minutes. So we're all done, yay. How to test it? Well, curl is a good option. So curl, this will get your data because by default it will use the get. If you need to send the data, X, capital X, post, and then of course send that JSON. So one thing about DynamoDB, it would not create IDs for you. So that's why I'm using this $UUIDgen. It's just a Linux and Unix function to give me a random number. Yeah, it's truly random. So yeah, you cannot have duplicate keys in DynamoDB. MongoDB will do that for you. MongoDB will create the IDs for you. Does CouchDB create IDs for you? No? Haven't worked that much with CouchDB. Okay, so yeah, we can change this API URL, and we can post many times. This is what you would see when you actually go into your DynamoDB. So the Web Console, the Amazon Web Console, it has a nice overview. You would see the tables, you will see the records as well. So you don't need to know the DynamoDB command line interface in order to test, to validate your data. This is Postman. If you haven't used Postman, you haven't tried it, it's a nice GUI client that has a graphical interface. You can save your previous requests. So basically a client to make requests, usually for testing, for web development. It's pretty nice. So when you use it, don't forget to set body to raw and to set application.json. Okay, because as you can see, there are other configurations such as form data, form URL encoded, binary, etc. So it's very important to send the right format. Otherwise, your Lambda function would not understand it. This is an example. UUIDgen. This is created kind of manually for me. And yeah, we can delete it. So, ta-da! We've built our, at least some of us, we've built our RESTful API. So yeah, I know it's kind of end of the day, lots of commands. So that's why That's why I have it on the GitHub repository. Don't forget to delete it, right? So delete it. Some services, they will be charging you if you don't use it. Not the Lambda. So the good thing about Lambdas, we need to talk about that. It's event-driven, which means it's only charged when it's actually running, right? So it just stays in the cloud. It's waiting for commands. You're not being charged, right? And that's good. So some operations, you don't need a server. You don't need a long-running process because it just happens once in a while, right? So why have an EC2 always running? Why have a virtual machine always running? With Lambdas, you can optimize and save costs, right? Up to 5 minutes, your function can run. If it's longer than 5 minutes, they have a limit on 5 minutes, okay? So something that takes a long time probably is not good use case for Lambdas. And also you have a good, I think, 1 million requests on the free trial account in AWS as well. So in some cases, you won't even pay anything because it's going to be under your trial limit. But still, it's nice to delete. So there is a delete function and DynamoDB delete tables as well. Okay. So we went through that using the low-level AWS CLI. You can use the Web Console. Some of the steps will be automated for you in the Web Console because they have nice wizards. I've used Microsoft Azure as well. AWS Web Console is much better in terms of the interface. They have those question marks. You can just hover on them, and it will show you the explanation. So that's one of the ways. Another way is like low level, what I just showed you. The AWS CLI allows you to do everything that you can do with the Web Console, but sometimes you would have to write like a bash script like I did, right? So maybe that's what you need because you need something very custom, right? In other cases, take a look at Serverless framework. That's just the name of the framework, and it allows you to basically, it abstracts a lot of those steps for you. And you can switch between AWS to Microsoft Azure and Google and IBM cloud providers. Cloud.js is kind of a new kid on the block in terms of the serverless frameworks. Also consider using it, so just install it with NPM, and basically you upload your file, create a project, upload your file, and it magically works. Some of the tutorials that I wrote, all in public access on internet. So AWS CLI Web Console tutorial, building Node.js Hello World server using AWS CLI. CLI and the Web Console, creating WordPress, etc., etc. Also, I have 3 courses on Node University, AWS Intro, AWS Intermediate, where I go. It's nice quality recorded videos without pauses, without awkward silences, AWS Intermediate. It's not like one of those crazy 50-hour courses, like who has time to spend like 50 hours on a course. It's like in the 4 hours you will get to good level with AWS and SDKs. And then Node in production. If you're a fan of Node.js and Docker containers, that will get you started with that. So this tutorial is part of the AWS Intermediate. You can find the lab on the blog post as well and the code as well. And the videos are on Node University. I put a chair over there. I have discounts for Node University. Running a promotion, 80% discount. So grab one of those. If you have any questions, I want to open the floor for questions. Yes?
Yes, probably a couple of questions. I've been exploring all this world with serverless. Unfortunately, I haven't been success because some of the processes that we run the company that I work for cannot be achieved. One is we're all like really tied to be connected to internet and to be always using the AWS console. The second is we cannot replicate the testing layer that we have because it seems like you don't have the ways to do unit testing, functional testing, and some other things in AWS. Probably you have some information about that. And the third is even after going to the AWS framework, the serverless framework, it seems like if you really want to use it, you have to use a single account which has a full number of permissions, which is opens the security to build
Yeah.
a big base.
So it sounds like you outgrown the serverless framework. You have to build something custom like this, like a bunch of AWS CLI scripts and probably some combination of CloudFormation as well.
Okay.
Yeah, so CloudFormation is just a declarative way. In a JSON file, you just specify all the resources and you send it, and they will be deployed and provisioned.
Okay.
Yeah, so that's the downside of frameworks. They are opinionated in advance. They do a lot of things for you, but in large projects, you tend to fight with them a lot. So it's better to like switch into more level technologies. More questions? Yeah, grab one of those discount codes. Limited time offer, not university. Thanks for coming, and I'll be talking about state of JavaScript in the next room. So if you're new to JavaScript or just not keeping up with the current state of JavaScript, I'll see you in 10-15 minutes in a different room. I think it's, thank you.
Not really.